Good morning, dear students. So today I will be dealing with the topic called basic operation on signals. So it depends upon two variables, that is dependent variable and independent variable. The dependent variable corresponds to amplitude or the value of the signal, but the independent variable is time dependent. Once again I will repeat, dependent variable depends upon the amplitude of the signal and independent variable depends upon the time scale. This is what the difference between dependent variable and independent variable. So dependent variable is having some operations. Those operations are amplitude scaling, addition, multiplication, differentiation and integration. These are the different operations which will come under dependent variables. So the very first one is amplitude scaling. So let x of t be a continuous time signal, then the signal will be y of t into x of t. So in this case, if you want to get y of t, you have to multiply the scalar quantity or a scalar form into amplitude. That x of t is an amplitude and c is a scalar. So then you are going to get y of t. That y of t is nothing but the scaled version of a signal or a multiplied version of a signal or amplitude version of a signal. Next is the addition. So before that, you can have a look at this equation, that is y of n is equal to c of n. This is in terms of discrete time signal and this is in terms of continuous time signals. So in terms of continuous time signal, we are going to use x of t. In terms of discrete time samples or discrete time signal, we will be using x of n. That is what the difference is. The next operation is x of t. X of t, we just have to remember this equation, that is y of t is equal to x1 of t plus x2 of t. If there are two signals are there, then how to add? So we just have to add x1 of t and x2 of t. This is what the addition is. That is in terms of continuous time signals. In case of discrete time signal, it is x of n plus x1 of n plus x2 of n. Then you are going to get y of n. In multiplication, so you just have to multiply the two signals. In place of plus, you just have to put a dot or a multiplication signal. So here it is, that's x1 of t dot x2 of t. This is an operation of multiplication. So next is the differentiation. So let x of t be a continuous time signal, then the differentiation of signal with respect to time t is defined as y of t is equal to d into x of t divided by dt. So you have to differentiate the given signal. So they are going to give some equation. First you have to differentiate that equation, that is that x of t, then you are going to get some values. So using that values, you need to plot the signal or a samples, it depends, then you get y of t. Next operation is that is integration. So integration, it's in the range of minus infinity to infinity x of tau into d tau. This is what the integration is. Integrate and draw the signal or sketch the signal. So here it is minus infinity to t. This is what the range. So within that range, you will get different samples or different signals. You just have to club it. Integration is nothing but an addition of all the signals. That is an integration, and these are the operations which will come under dependent variable. And the next is independent variable operations. This is very important, independent variable operations. So in this, you will come across three operations, that is time scaling, time shifting and the reflection. These are the very important operations in independent variable. So in that very first one is time scaling. You can have a look at this time scaling. So time scaling is having an equation called y of t is equal to x into a of t. So in that a, if the value of a is greater than 1, you can have a look at this. If the value of a is greater than 1, the signal is compressed. Okay. If 0 less than a or less than 1, or less than, if it is less than 1, if a is less than 1, then signal will be expanded. So in first case, if a is greater than 1, if a is the value of a is greater than 1, the signal will be compressed Make a note of this word compressed. If a is greater than 1, signal will be compressed, and if a is less than 1, the signal will be expanded version of x of t. Just remember this: if a is greater than 1, compressed; if a is less than 1, expanded. So this is an example what they are given. So, and this is numerical, small numerical, that is in place of a they have written 2. Look at this, the signal x of 2t. So x of 80 is there, in place of a they have written 2. So 2 is it is greater than 1. So if it is greater than 1, then your signal should be compressed. So how it will going to compress? So you just have to divide the time scale by 2. So that is minus 2 by 2. So minus 2 by 2 you will get 1. That is minus 1. So minus 2 and divided by these 2. So you will get minus 1. That is what the result is. Here it is minus 1. So next is at minus 1 by 2. That is minus 1 divided by 2. This will be 0.5 or half. Look at this. This is at half. Okay. Next, this scale 2 plus 2 divided by this 2, you will get 1. 1 divided by this 1 divided by 2, you will get half. The signal is there at half. Okay. And this scale on y-axis, the amplitude remains same. Why it remains same? So this operation belongs to independent variable, not on dependent variable. So earlier I told that dependent variable operation depends upon the amplitude. So that's why this is not varying. The amplitude is not varying in case of independent variable. The variable is the only variable is the time scale. Amplitude will not going to vary. So this 2 is not varying because this is an amplitude. This amplitude belongs to dependent variable. Time scale belongs to independent variables. Now we are working on independent variable. That's why this time scale is varying. So got it? X of 2t, the signal will be compressed version. So next operation, next example is if x of, so I think I have missed that page. We'll explain it in the next class. So generally I will explain. If it is x of 1 by 2, x of 1 by 2 into t, x of 1 by 2 into t, you just have to divide this 2 by 1 by 2. So what happens? Minus 2 divided by 1 by 2. In the denominator 1 by 2 is there, that 2 will come into numerator. So that will become minus 2 into 2, that will be 4. So this signal will land at minus 4. So next, 1 minus 1 divided by, the value is 1 by 2. So minus 1 divided by 1 by 2. So again the 2 will come in the numerator. So this signal will land at 2. Next is at 2 divided by 1 by 2, it will be 4, and this signal will land at 4. Next, at 1 divided by 1 by 2, you will get 2, and this signal will land at 2, exactly at 2. That is an expanded version of a signal. This is a compressed version, and if it is x of 1 by 2, then it is a expanded version. So 1 by 2, you just have to divide the time scale by 1 by 2. minus 2 divided by 1 by 2, minus 1 divided by 1 by 2, 1 divided by 1 by 2, 2 divided by 1 by 2. So that is the operation about time scaling. The next is time shifting. So how that operation will take place in time shifting. So here they are going to consider the equation called y of t is equal to x of t minus t naught. So considering that equation, in place of t naught they are going to write some values, that is 2, 3, 4, like this. It depends. So if it is plus value or minus value, it depends upon the axis. It depends upon the axis. For example, if t naught is greater than 0, so we have considered the equation, that is y of t is equal to x of t minus t naught. In the previous class I explained about this. That is y of t is equal to x of t minus t naught. In that, if t naught is greater than 0, the waveform of the signal is shifted to the right. If in case t naught is less than 0, the waveform is shifted to the left. That is what the operation is. So this is an example. This is the basic example. This is the example what they are given. So continuous time signal, this is the example, and what they are given, x of t minus 2 and t plus 3. So what they have said, if t naught is greater than 0, the waveform of the signal is shifted to right. So look at this, x of t minus 2, so that will be x of, you just take t minus 2 is equal to 0 and t is equal to 2. So that means 2 is greater than 0 only. So if 2 is greater than 0, it has to shift to the right by 2 samples. By 2 samples. Look at this. This is the first place. This is the origin place, and this is the first place. This is the second place. T minus 2. So it is greater than 0. If it is greater than 0, it move towards the positive axis. If it is positive axis, it has to move towards the right, that is by sample 2. This is 0, 1, 2. Your signal, this point of signal should have to land at 1, and this signal should land at 5. The same signal is shifted towards the right by 2 samples. And if it is t plus 3, x of next example is if t plus 3. You take t plus 3 is equal to 0, then t is equal to minus 3. If it is minus 3, then it is less than 0, then t less than 0. So if t less than 0, so t less than 0, your signal has to shift towards the left. So that's what they have done by 3 samples. Look at this, 2, 3. Left version, 1, 2, 3. 1, this is first shift, this is 0. You have to consider the original signal. This is the original signal. Don't consider x of t minus 2. Consider the given signal. T plus 3 means therefore t plus 3 is equal to 0. Then t is equal to minus 3. That minus 3 is less than 0. So it has to shift 3 samples left. So this is the first point, second point, and this is the first point. This point has to come at the origin. Look at this, origin, and the tail has to land at minus 4. This is what the time shifting. Next is the reflection. Reflection is nothing but an mirror image. Look at this. This is the given continuous time signal, and if it is a mirror image or reflection, it will look like this. It's a replica of the basic signal. So this is what the basic operation. It depends upon the dependent variable and independent variable. In the next class we're going to start the problems. We'll start the problems from next class. So be prepared and thorough with all these basic concepts. Thank you.